What's up, everyone? Coming to you live from Data Innovation Summit 2020. I'm here with some really cool guys from HP that are going to talk to you about some of their neat software and hardware that they have both here in their booth and that could potentially be at your place as well. Please introduce yourselves and tell me a bit about what you guys are doing in data science.
Yeah, so basically my name is Albert Brunner. I'm responsible for the Nordic markets here at HP in terms of data science. And what we do is that we do the move basically from being a hardware vendor to actually supplying you with solutions. So services solutions provider much more, and we're coming up with more and more of our own software. That's the idea from HP, to be more relevant in this field.
Okay. So you guys make workstations, right? And you have a wide, what do you say, selection of different workstations. But what do you mean that you're getting into solutions?
No, so actually it's all about the fact that the idea is that you need, of course, a computer to work on, and we're going to supply you that. But you can also, and it's not only about hardware and having the right hardware, but also to make it work for you. So the idea that we supply you with the right software for the machine, with the right amount of power and all the GPUs that you need, and to make it work basically, be more creative.
Yeah. Okay, so what kind of tools do data scientists, I mean, the thing is, it's quite nice when you have a machine and out of the box you can just be productive with the machine. Like, what kinds of things do these machines come with?
Yeah, so basically that's the idea here, that we can supply you with the right machine, with the right software out of the box. And we can also ensure that it works, and you can get it with Windows subsystem Linux. So you can get it both with Windows and Ubuntu in parallel.
Right.
So you can be very productive from start, basically.
Yeah. And you have so of the different branches of products that you have, I think a lot of people are familiar with HP products because they have them at the office. And I see like a laptop, for example. What is this product line? This is the...
It's the workstation series. Basically, when you work in data science, machine learning, AI, you need power. So the idea is to keep you guys creative.
Okay.
So everything should run fastly and smoothly. So it's the Z series from HP. It's a brand that's been around for about 10 years, and it's the powerful machine, so to speak.
Yeah. I think one of the things that stands out to me for these types of machines compared to, say, you know, the thing that you might be able to build at home or whatever, is that you can pummel these machines with work, and they can stay hot, they can work for a long time, and you know, be reliable.
Yeah, and that's the idea. You can rack mount them as servers, work remotely, and yeah.
But this is a kind of machine that you would have next to your desk at the office, right? It's not one that you would necessarily have to lock into like a room somewhere else.
Yeah, absolutely. That's the idea.
Is it loud?
I think it's loud if you push it.
Yeah.
Otherwise, not.
I think when I've seen demos of it, when everything is on 100%, it's blowing a lot of hot air out.
Yeah.
But I've been in some pretty quiet rooms with those machines. You know, when you're just working and programming and not maybe compiling or something, they're very quiet.
Extremely quiet.
It's annoying to have a machine next to you that's taking off, you know, all the time, or some laptops. And I guess that's the equivalent in the laptop, right? Because you said this is a workstation laptop.
Exactly. The same thing with the portable ones.
Yeah.
The idea is to push them.
What's the main difference between a workstation laptop and, you know, a laptop that has a Core i9 or something like that?
The big difference is that we get all the workstations with GPUs, powerful GPUs, and you can put more RAM and of course more video RAM on the GPUs.
Yeah.
So
can you run the laptops hard like the workstations in the same way and let them be on? 100%?
Yeah, that's the idea, that you are be able to push it as well, and much more fans and being able to use it for a longer period of time.
You were talking about the images and providing software out of the box. I mean, that is a large part of what organizations do when they prep the machines and that kind of stuff. Is that the kind of sort of collaboration with organizations that you envision being part of your service, where organizations have an easier time preparing these machines for data scientists to be productive as soon as they get them? Or Is it an ongoing service that's direct with the data scientists, or how is it going to evolve, rather, I guess? What's the future of this?
The future, I think, is it's both. It's to be ensuring everyone to be productive from day one, but also to keep productive, and when you do the updates of all the different parts of your system, to ensure that it's going to keep working.
Yeah.
So that you're not going to end up in the hassle of needing to reinstall everything.
Yeah, and now we've only mentioned some stuff that people are familiar with, like Windows Subsystem for Linux and that kind of thing, but you also have a lot of really interesting software that's HP specific, like remote desktop software and other stuff that's really top of the line. You want to tell us about some of the neat tech geek stuff?
I can tell you some of the stuff about it. First, I think I should introduce myself.
Yes, please.
So I'm Paulius Danėnas. I'm a senior data scientist and machine learning engineer. I come from Intellerts. We're doing partnership with HP, so we're helping them to set up all those softwares, let's say, to improve everything. And in this case, Albert has mentioned that we might, let's say, apply the expertise that Microsoft has developed by developing BSL2 to leverage the whole power of it and to use it to run Ubuntu-like systems right under Windows. So, well, you know, this is kind of very interesting cases for let's say business companies as well as data scientists who are used more like on working on environments like Windows. Well, one of the reasons is, for example, maybe compatibility of some software, particularly on operating system. For example, I can say that software like Tableau, maybe, I don't know, Ulix. Well, again, the ones which can run, which are, let's say, OS dependent and can be run only on Windows. So, but naturally, they need to run to work with some specific frameworks, which are, let's say, are better manageable, are better runnable directly under Linux-based systems, and this is where our solution, our proposal, comes into as one of the best options that could be used to solve this problem.
Yeah.
So as we can see, that we have some advantages of WSL.
I think for people that aren't familiar with WSL2, it's not immediately clear exactly how flexible it is because, like you said, there is a lot of software that only runs on Windows that's important to enterprise environments like Tableau and so on. And that you know, to be productive in your enterprise environment, you need to have that stuff. So what, are you going to have two computers? But then the nice thing is, this is actually real Ubuntu, right? It's not like a fake version. I mean, it has the Linux kernel proper. You can run CUDA on it. You can even run Docker and containers, and they'll be GPU accelerated and everything. So it is your real environment. I think that's pretty cool.
So you have the benefits of both, let's say, both worlds. You can, let's say, you can install the system directly under Ubuntu. And again, there's quite a lot of open source software which, let's say, was developed under Linux, which is used under Linux. Well, it might be maybe compiled or run under Windows, but it might be too complicated, and it might take too much time even to adapting it to this environment, and or just to get it working good.
Yeah, you want to do your Node.js stuff and that kind of stuff maybe in Ubuntu, and whatever, you can have them as entirely separate environments.
Yeah, exactly. So what we can say here is that we established a kind of a software stack that which I would say almost, well, maybe not almost, but most of the data scientists are more than familiar with. Well, they might be less be familiar with frameworks like maybe Rapids, which is very improving very fast, and this is a solution offered by NVIDIA, which allows you to perform the whole processing directly on GPU. But most of other stack should be quite easy to start with, and at least to get it going with. So this is the core selection, and I suppose this is not a finite list. I suppose it could be extended later with additional languages, additional technologies.
Yeah.
I think we can add support for our language, especially, again, Julia language, if there's a demand for it.
Yeah.
So this is quite...
The cool thing about this is how transparent it is, because I had a chance to work with it, and you know, it's nice that it comes out of the box, but really, in terms of developer experience...
Still not getting used to this.
Yeah, that thing is tricky. In terms of developer experience, Albert, that was something we were talking about before, where, you know, your experience as a data scientist at a company, if it's subpar, you're not going to afford yourself experimentation.
Yes.
You're not going to be enjoying your work at the workplace. As an employer, you're going to have a hard time attracting the people that you probably want to bring into the company to do this kind of work. But the cool thing was, all the way from, you know, PyTorch, Rapids, down to Visual Studio Code, Git, having your Git repo in Windows, having your Git repo in Linux, it all works very pain-free just out of the box. You don't have to sit for hours and configure stuff, and that's... it was fun to configure it the first time, right?
Yeah.
And then you don't want to do it again.
Yeah, believe me, I know that the pain of configuring everything first time. So this is very much of a help for let's say data scientists who may not come, let's say, from the field of scientific computing, or at least for software engineering, where they are used to configuring something, installing something. But again, for scientists, well, let's say for data scientists which come from the field of mathematics, applied mathematics, statistics, I think this is a much better option just to get started with it without any hassle, to trying to at least get something working on.
Yeah.
So, I'll also talk about several of the core tools. I think many data scientists will be familiar with some of the tools, but I'll introduce some of them of the, let's say, core tools which, let's say, the stack is built around. So, well, first I would like to mention Rapids framework. So, it's, as I mentioned, this is the tool that's developed by NVIDIA. Well, I think every data scientist is used to working with data frames, in one environment or in another environment. So again, in Julia or in R or in Python especially, everyone is familiar with them. You know, pandas. So, what is Rapids essentially is this is a kind of a framework which allows you to push all the at least most of the computations directly to GPU and execute almost all computational workflow directly on GPU without, let's say, converting data, pushing data back to CPU, then pushing it again to GPU, and so on, which naturally takes a lot of time, and it's not as computationally efficient as it could be. So this is so these charts are, let's say, taken from the NVIDIA website, and they quite well introduce, explain the whole concepts of it, and they can easily show why Rapids is so becoming so popular, while it's becoming more and more, let's say, as required for real-time data processing workflows. So we can actually compare, let's say, more traditional pipelines like Hadoop processing, like Spark in-memory processing, well, traditional GPU processing, and we can see that by applying Rapids, that the amount of time required to perform particular calculations, it might be reduced quite drastically, even important to even more than 100 times compared to, let's say, to some other traditional pipelines. So this is also quite an interesting...
This one is super interesting, precisely because right now you're doing a very fair comparison, but the comparison is more unfair than this to the advantage of doing things the Rapids way. The thing is, you get so spoiled working on these machines because if you have like an 80 gigabyte CSV or something, you just load it and it works. Even the laptops that have the Quadro cards, you can just pull the data straight into memory. Whereas with Hadoop, it's like, this is what the time it would take if the data's ready, and you know. But that's not how it is. You have to put it into HDFS. You have to spin up the cluster. You have to load all the stuff. So you really get spoiled when you have machines like this, and you can just take ridiculously large data sets and just play with them on your local machine.
Well, naturally, you might get constrained by, let's say, by the amount of GPU available, but again, you can also apply distributed computing, like on tools like Spark or Dask, which is, again, one of the main advantages of RAP is that you can apply distributed computations and just run the computations quite efficiently there. So another tool, another tool is, I think it's very well known as for data scientists, well, at least the ones who are more familiar with deep learning techniques. Again, still not getting used to this.
There we go.
TensorFlow is, I don't know even if I'll need to talk about it quite extensively. This is almost the standard de facto framework in deep learning. So everyone who's familiar with Google, everyone who's familiar with deep learning, so they know that almost all the stuff they do is developed on using TensorFlow. So this is the platform which enables you to develop those kinds of wonderful things which are, let's say, shown by Google, which are shown by NVIDIA.
Yeah.
So this is kind of a tool which makes very proficient and very, let's say, efficient by developing new techniques in data, in deep learning, new types of architectures for deep learning models, like especially GANs.
Yeah.
So this is also very
What else
well-known
is
tools.
included?
Yes. So again, the main advantage here is, again, it might be quite sometimes it's quite a hassle to configure it.
Yeah.
Especially using when you consider different CUDA versions. So this is where we try to help those data scientists to get everything started and going in the fastest way that's possible.
But like we said, it was fun to configure it once the first time, and then you don't want to do it again.
Yeah. So
I want to give the viewers a chance to get to know one thing, because the thing is, it's one thing to see these slides here. It's another thing to get to try it yourself. And I think the most important thing is to give people the opportunity to try these things out and get to talk to you guys and see sort of what can be done for them. Because a recurring thing that we've been seeing in all the panel discussions here is that when it comes to these projects, productivity, I mean, the investment is already there, right?
Yes.
Money isn't generally a problem when it comes to these initiatives, and what they want for you to be is to be productive. You need to hit the ground running. You need to feel inspired to do good work. So for all the data scientists out there, for the decision makers, Albert, if they want to sort of get a feel for, you know, what these machines could do for them and what they, that kind of thing, where should they turn to? Should they turn to you?
They can turn directly to me, or they can turn to their contact at HP or their supplier.
And ask for what? Data science?
Basically, tell them that you work in data science. You're going to get in touch with the guys at HP within data science.
Yeah.
And I actually have the possibility to lend people these types of extremely powerful machines prepared with the stuff that we just saw.
I highly recommend this.
And WSL2 and Ubuntu.
If you guys have cool use cases and are doing heavy work that would benefit from these types of workstations, it's such a pleasure to work on a nice machine like this. So I would urge you to get in contact with Albert and the gang and see, you know, if they can find something that fits, you know, your use case. That's all we had time for today, but...
well, and to finish up, so we have yet another, let's say, framework which is also quite well known.
Yeah, PyTorch.
And apologies. So I think you know what is kind of architecture is displayed
some kind
here.
Of transformer, maybe?
Yeah, exactly. This is the original transformer. So this is, let's say, the wonder that powers most of the recent developments in deep learning.
Yeah,
so you can find its applications everywhere.
So if you want to get started with NLP and that kind of stuff, it just works out of the box on your workstation.
Yes. So
nice.
PyTorch has wonderful library, even called transformers, which enables you to just develop state-of-the-art NLP solutions. So that's why this is, I think, one of the most mandatory tools, which is also comes into this data stack of HP. And naturally, this is I think an awesome news for those who are working with state-of-the-art in deep learning here as well.
All right.
So, and naturally, there are several other tools. Like Git, Visual Studio, again Python. Naturally, you need to install additional libraries, which is quite natural. But again, those, let's say, are the core tools. And I suppose this is not, as I mentioned, I suppose this is not the final list. Naturally, a lot of data scientists will argue, they will tell us that, okay, we'll need additional tools. So, well, it is possible to add
an ongoing process.
additional tools. Yes, it's an ongoing process, and naturally, the amount of tools that the data scientists will be using it to develop their own solutions will be just increasing. This is an ongoing process, and I'm sure that it will not stop.
Cool. Thank you both for joining.
Yeah.
Shame you guys, if you're here, you're obviously visiting the booth. That's super cool. But like I said, please look these guys up and see what they can do for you. I will be seeing you guys very soon at the next discussions. Thanks for joining for this one.